Hi everyone, welcome to Axiom. So today we are going to calculate time dilation due to gravity and time dilation due to velocity in Python. So without any further delay, let's get into the topic. So first I have stored all of the calculations and code in a file called time dilation. It is written in a traditional Python script, and it includes both code for time dilation due to gravity and time dilation due to velocity. And what we are going to do is what I am going to do is to explain these codes line by line to you so that you can generate your own code with this idea. So first, let us look at the file. First, we want to generate the code for time dilation due to speed. So let velocity. So let's calculate it. The time dilation due to velocity. So the first we need the libraries. So the libraries we need for the calculation is matplotlib first, and numpy, scipy, specifically the constants in scipy, and math. So we need 4 libraries for the calculation of time dilation in this code. So we are going to copy these libraries. These libraries are very important for our calculations. So let us copy it and paste it here. So we have successfully added all the libraries that are needed for this code. So next we are going to generate another block of code. So this block of code includes the variable of speed of light. The variable of speed of light is very important because it is the main thing we are going. This is required. This is the constant that we require for calculating the time dilation due to speed. So the const is, we have imported the scipy.const as const. So because of that, we are using the word const as here. The const dot speed of light. This is constant called speed of light in the scipy library. So we are extracting that and storing it a variable called speed of light. So we have. I hope you understood it. So next is the important thing. So this is the formula for calculating time dilation due to velocity, and the change, this del t, is the change of time that is occurred due to gravitational time dilation, and this is the change in time that is unaffected by the gravity in a place, in the specific place. For example, Earth. The Earth's gravity is very low compared to massive objects like black holes. So because of that, we neglect the small amount of time in that. So we consider Earth as a place with less gravity or no gravity. So next is the Lorentz factor. So this is called the Lorentz factor. I will show you the Lorentz factor. This is the Lorentz factor. So we can also state that the change of time in an unaffected, gravity is unaffected. Gravity is unaffected. We can also say that when we are multiplying the time, to the Lorentz factor. So we consider there is no gravity in the. We consider no gravity is the occurrence of no gravity is there in the traveling time. So if it's traveling in space, we consider that there is no gravity interruptions in between. So then only this formula will work perfectly. So this is the formula, and we are multiplying the change of time, the velocity times the Lorentz factor. This is the change of time, and change of time is multiplied to the Lorentz factor, and with this we can calculate the time dilation. So this is the v. This is the velocity that object is traveling at. That del t is the change in time. So we are going to input these two parameters in our function. So this is the function of time dilation due to speed. So the functions, we have defined the function. The function's name is time dilation, and the parameters are the del t, which is the change in time, and v is the velocity. So we are storing the speed of light. We have already stored the speed of light in a variable. So we are storing the speed of light in a variable called c in this function. So the next is the if statement. This if statement is very important because it is the main thing in this formula. So the if statement is, if v is greater than or equal to c, which is the speed of light, which it states that if the velocity is greater than or equal to the speed of light, raise value error, which states velocity must be less than speed. So this is the value error that occurs because we know that nothing can exceed the speed of light. We know that it is physically, scientifically impossible to exceed the speed of light or match it. So because of that, we code the value error. This is very important. This value error is very important because it is the base of the formula. So next is the return. If a function has a parameter, it would output a value, right? So we have to output the value. So the output value is this is the formula. This is the formula that we saw. This is the formula that we saw, the del t, the change in time, and the math dot square root. So square root, we have to use the library called math for the square root, and we are just multiplying the Lorentz factor to it. So as this is a Lorentz factor, we are multiplying the del t to the Lorentz factor, where the gravity is unaffected. This is very important, where the gravity is unaffected, to get a perfect result. Because it is a time dilation due to speed. I will explain time dilation due to gravity further after this. So we are only considering the time dilation due to speed in this formula. So next we want to get an input, right? So the input we are getting from the user is the time. Obviously time is the change in time we want to input it. So first is the time is equal to float. So we will enter it as an integer or a decimal value. So we are using float as the parameters type, and we will raise a value error. I will include error handling in every input because the code should be perfect, right? So there will be error handling in every input. So this error handling input states that if this input is string, it will raise a value error. So time should not be string. So we are specifying that. So we are going to copy this and paste this because I'm just explaining this to you line by line. So this is the input for time. The next is the input of velocity. This input of velocity, I have included two types of parameters. One is the ratio between the velocity and the speed of light. The two is meter per second, standard, the SI unit, meter per second. I have included both the SI unit and the ratio between velocity and speed of time. So for example, if the velocity is speed of light, it will be impossible, it won't be the amount of speed of light. But if we are considering the velocity speed of light, the ratio between the speed of light will be 1 because it is equal to the speed of light, right? So the ratio will be 1 in this situation. But it is scientifically impossible. I am just telling it to get an understanding for you. So the ratio will be 1. And the next is the meter per second. I will show you how to access meter per second. I have stated that meter per second, if we can't calculate, because we are generating this code to calculate, so we can't do excess calculation. So if we want the input parameter to be meter per second, I will show you how it is done. So we will copy this and enter as a block of code. So we have all set the constants, we have imported the libraries, we have defined a function, we have aggregated the inputs. So the final thing we want to do is output, right? So the output is done through printing. So let's print the value. So we will add the code print. We will add the code because we want an output, right? So time dilation is the function and the inputs. So we have included the order of the input is very important in Python because it's an ordered list. So in the function, okay, I have not included the function. So let's include a function in the code. So let's include the function in our code. Let's include the function. So we want the function to be at top because the order of this can influence the output, and because of that we are doing it upwards, going it upward. Next is we have to print the output. The thing we want to do is The order is very important, as I already said. So first, in the function we have added del t, which is the time. So time is our input here, time, and the next input is velocity. So let us run the code and show the output to you. So let's enter the time. The time I will consider as 60 seconds. Enter the velocity. So if I want the ratio, if the velocity is times lesser than the speed of light, we will enter 0.1. As I already said, the ratio thing. But if we don't want the ratio, we don't know the ratio, we don't want to calculate it. Just press the enter key and the parameters will switch. The type of parameter will switch. The type of parameter in this is the velocity, meter per second, the SI unit of velocity. So let's enter the SI unit. Let's enter 3000. Let's enter this value. Okay. So this will be the speed of the object traveling, and let's click enter. So the value is 60.003. So what the input parameter was 60 seconds, but it dilated to 0.003. It dilated. This is the time gap we can see. So the 0.003 seconds has been dilated due to the speed of the object. So speed dilates the time, and this is the time dilation happening due to high amount of velocity. So the next thing we are going to do is calculating time dilation and plotting it as a graph. So we have already calculated the time dilation due to velocity. So we are plotting it in a graph. Let's see the relation between the velocity and the speed of time in a graph. So it will be the understanding will be even more higher because we are seeing it as a visual. So because of that, the understanding will be higher. So this is the code that we have created for the graph. So this is the velocity. So the x-axis is the velocity. So we have used NumPy, the NumPy library as NP. This is the NP. This is called NumPy. So the NP's line space function is used. So from 0 to 100, with the difference of this, we are plotting the x-axis. In the x-axis is the velocities times the speed of light. So this is the ratio. The ratio is getting times the speed of light is the x-axis. The time will be the y-axis. So the time is the list we are using the map function, and lambda v, the time dilation velocities. So we are calculating the time in this particular variable in the lambda function. So time dilation is the function here, and this is the velocity. So we are using the velocities as the variable here, input here, then in the lambda function. So we are using lambda function for this, for a simplification. So next is the plot. So this is the x and y axis, and next is the plot. The plot is this is a PLT dot figure, which sets the figure size, and next is the PLT dot plot, which plots the velocities by speed, times, and labeled as a time dilation. The title will be time dilation, and it plots the velocity by speed, it's a ratio between them, and time, the time axis, y axis. Next is x label. The x axis label will be velocity, fraction of speed of light. The ratio is same as the fraction. Next is y axis, which is the dilated time, which is the y axis, which will increase over as we get closer to the speed of time. And next is the title. The title is just time dilation as a function of velocity. Next is the legend, grid. The grid will be important, and the legend is for understanding. Next is show, the PLT dot show, which displays the graph to our computer. So let's copy it. And we'll create another block and paste it here. Okay. So next, let's run this. So as we enter the time, we'll just enter. So this code running time is pretty higher, so it will display it will display the graph. This is the graph. So this graph, as we can see, as it gets closer to the speed of light, this is the fraction. So I have already told that 1 will be the ratio of the speed of light is the velocity. So as we get closer to the speed of light, like 0.9999, it's the fraction, will be the fraction. It's not manually possible, but we are considering here. So as we get close to the speed of light, the dilated time will be increases in seconds. As we can see, the dilated time will be very less in this situation. But if it gets close to the speed of light, the dilated time will be increases, and at speed of time, we don't know what actually happens. We have all hypotheses, but we don't know what actually happens. But as we go near to the speed of light, the dilated time will be increasing exponentially. It will be very as we get very close to it, it will be drastically increasing, as you can see it on the graph. So this is how we can plot the output of the gravitation time dilation due to speed as a graph. So let's get into gravitational time dilation, which is the time dilation which is caused by gravity. This is the time dilation that happens in the film Interstellar. So you may have watched it. So let's get into the topic. So this is we have the source code for the time dilation, and we have also stored the gravitational time dilation in the file called time dilation. So let's get into the file, which is a Jupyter node. So first, let's import a library. So we don't need the matplotlib library because we don't have to generate any graphs in this code. So we only need NumPy, SciPy, and math module. So next variable we need is the gravitational constant. The gravitational constant is needed for the calculation of gravitational time dilation because it is very important. So this is the function. This is the function for calculating gravitational time dilation. So we have also have the speed of light for gravitational time dilation, but we have another constant. This is the gravitational constant. Gravitational constant is also used in the calculation of gravitational time dilation. So I have stored the value of gravitational time dilation, gravitational constant in the gravitational time dilation's function as G, capital G, in a variable, and next is the returning value, which is the del T. So the formula for the gravitational time dilation is the del T times math square root of 1 minus 2 gm by r square, r times c square. 1 minute, I will explain this. So del T is the change of time, which is the change of time unaffected by the gravity. So we are returning the value, right? So it is the formula, plain formula. So this is the change in time unaffected by the gravity. So next is this math. We use math to square root the square root, and 1 minus 2 times g times m. M is we have two parameters. I forgot to tell the parameters. We have three parameters in calculating gravitational time dilation. One is the change in time, del T, and next is r. The r is something, the radius of the celestial object. I will show you this. Think of the sphere as our celestial object, and the distance from the center of the celestial object to the radius, to the edge of the celestial object is called the radius. In the sphere, let's consider it as a celestial object as a sphere because we are actually approximated it. So let's consider it as a sphere. So it is also known as Schwarzschild radius in black hole. So black hole is considered as a sphere. So the radius of a black hole is considered as it's called this Schwarzschild radius. So we are inputting the radius in this thing, and next in this mass, the mass of the object. This is we are mentioning this as a capital M. So the formula is 1 minus 2 gm, 2 times the gravitational constant times the mass divided by r times, which is the radius, times c square, speed of light, which is dividing to the numerator. This is the denominator, and this is the numerator, and this is the denominator. So let's copy this function. Before copying the function, let us look at the inputs first. So as I already told, we use error handling for the inputs. So first we need time, which is also used at the gravitational time dilation due to time dilation due to speed, which is also the time is also used. This variable is also used in the gravitational time dilation. So the next variable we're going to use is mass and radius. So first look at the mass try. So as usual, as same as the velocity, we had included two units in the ratio between the speed of light and meter per second. But in this, we are adding to the two units. One is solar masses. The amount of this ratio is between the mass of sun and the mass of the object. This is same as the ratio one. This is also the ratio. Next is kgs. This is an SI unit. So as if you want to switch the input parameter to SI unit, just click enter as the previous one. So let's copy it. Let's copy it and create a new block of code and paste it here. So this is the mass, the input of mass. The next thing is the center of mass, the distance from the center of mass, which is the radius. Center of mass, the distance from the center of mass to the edge of the celestial object is called the radius, and this is the error handling of radius. So radius also I have included two units. One is solar radii. This is the radii of sun. It's the ratio between the object's radius and the sun's radius. And next one is the kilometer, which is the unit for simpler understanding. Even though the SI unit is meter, I have added kilometer because if we include meter, it will be very big input. Next is, let's copy it. Let's copy it and create a new block of code and paste it there. Okay, now we have included the input of the radius, and let's straight get into the function. So as I already discussed the function is used to we have defined the function which is used to calculate the gravitational time dilation. So let's copy it and create a new block of code and paste it here. Okay, we have to mention the speed of light. So I have not included the speed of light in this code. This is the variable of speed of light, which is stored in this variable. Let's copy it, create a new block of code, paste it here and drag it upwards because it is formed, the code is run orderly. So because of that, we would place it up. So the code is ready. So we just need to output the code. So for output the code, we have the print function. So we also in this we also use the error handling. So if the dilated time is equal to gravitational time dilation, this is the function of the gravitational time dilation, and we have to print the value. We have converted this as a f string to include the value to the string. So we have printed the value, and if a value of error occurs, we just print E. So we just copy the code and paste it there. So as it's in up, it should not be in upward direction because the function is in the low. So it is also a common error in forming Jupyter notebooks. So we have completed our code for calculating gravitational time dilation. So let us implement this code into our real life. So this code has the mass as solar masses as base unit. So let us run the code. So let us take object as sun. Let us take the object as sun. So first we'll enter the time. So the time we enter will be 3600 seconds, which is 1 hour. Let's enter. So the mass in solar masses, which is 1. The mass of sun is solar 1. This mass of sun is 1 solar mass. So it will be 1 as the input. Also 1 solar radii. The output will be 3599.99 seconds approximately. So there is a dilated time of 0.001 seconds. So the places which has higher gravity, times run slower. So compared to bigger black holes, sun has very less amount of gravity. So because of that, the dilated time is very low. But at near some of the black holes, time dilation will be at its extreme. So because of that, time runs very slow compared to the place which has no influence of gravity. So this is gravitational time dilation explained to you through this Python code. So thank you for watching. So if you like this video, please don't forget to share, like and subscribe, and please share your opinion about this code on your comments, and see you on the next video. Until then, it's me Archit signing off.